Welcome. We're working with one of the extra lessons. I call them addenda to the Math 135 telecourse. This is lesson 2, and what we're going to do is go back over some factoring ideas that we kind of assume you've picked up in previous algebra courses, okay? But maybe you don't feel as comfortable as you'd like to feel. So let's do some work, okay? Now, how do we factor numbers and why do we factor numbers? Because you started doing that way back in elementary school. So like a number like 65. Why might I ever want to factor it? Well, factoring came in handy when I was working with fractions, like getting common denominators and so forth. Okay. So there are times that we'd like to factor it. Or maybe I have 65 cupcakes and I'd like to know how I can divvy those up. All right? Who knows? Now, as far as how do we factor it, when I look at the number 65, there's a huge clue staring at me. That's why I started with this guy, because I assumed you'd see that big clue as well. He's ending in a 5. So that tells me about a number that I know will divide into 65, okay? And I say, well, 65 would be 5 times, and if you're between a rock and a hard place and you're trying to find out what's that other number, we could just do long division, right? And we find out that that other number is 13. Okay, so how do we factor that number? Well, it helps if we know something about the numbers and the fact that if we multiply by a 5, it always ends in a 5 or a 0. Okay. Well, then what about this number 80? If we need to factor 80, we think, well, look, I know a 5 goes into it, right? Because if I multiply by 5, it ends in a 0 or a 5. I know a 2 would go into it. Why? Because it's even. I know a 10 will go into it. Why? Because it ends in a 0. By the way, what I'm trying to do is help you go back and remember those clues that you used to be paying attention to. So I could say, well, I'm going to use the 10. I just like that. And I'm going to say this is 10 times 8. Now, am I done factoring? No. That's why I picked this guy. Because with the 65, one time and I'm done because 5 and 13 are prime. But in this case, I am not done, so I break this down. That's 2 times 5. And my 8 is 2 times 4. And then you say, oh goodness, I have to break this down again. So I end up with 2 times 5 times 2 times 2 times 2. Or you could say that's 2 to the 4th times 5. So I have factored my 80. And the point was that I had some clues to get me started. Second point was that once I did one step, I was not done. You have to continue. In fact, I had to continue for 3 levels here. Okay? Well, how about the number 9,801? And you say, good God, I'm glad it's her and not me. Do you know any clues here that would tell you what to do? Well, one trick, because you see he's not even, he doesn't end in a 0 or a 5. But I can add up the digits. 9 plus 8 plus 1 is 18. Now that tells me that both 3 and 9 divide into this number. If you want, you can go and read some about divisibility tests or email me about that. But I know 9 is going to divide into that. And it would go in, let's see here, 1, 0, 8, 9. 1, 0, 8, 9, which is kind of interesting. You'll notice all I did was rearrange those digits. Guess what? I'm not done, because when you add up 1, 8, and 9, you get 18, so I know I can break it down again. I'm going to just carry that 9 for the moment. I know a 9 goes in there, and he's going to go in 121 times. And I say, yay, I recognize 121. I know he is 11 times 11. So I get 3 times 3 times 3 times 3 times 11 times 11. And if you'd like to write it with exponents, that would be 3 to the 4th times 11 squared. Now, by the way, what clues did I use here, or what do I want you to get out of this? First off, the idea that I had some divisibility tests, some cues to tell me take out the 9, okay? The idea that I had to keep going until I saw something else that I would recognize. Oh, 121, I'm good to go on that. And then I can happily finish it all off, okay? Now, I know this is numbers and you're concerned with doing polynomials, but I've mentioned before that a lot of algebra is just arithmetic, but with letters now, okay? Well, I commented here that since factoring is technically unmultiplying, it might help if we do some multiplying to get you thinking the way you need to think in order to go backwards. For example, like recognizing that 5 on the 65, the reason you recognize that is because you've multiplied by 5 many times. Okay, so we need to multiply here and then hopefully see some things as we go. All right, to start out with, one way we multiply is to simply distribute. I've got 3 terms, and all of that is to be multiplied by this negative 5x squared. So I distribute this times each of my terms. And I get negative 15x squared plus 20x squared y minus 40 x squared w. And you kind of look at that and notice that, wow, those are kind of big and ugly. Why did they get big and ugly? Well, because I multiplied. And do you see the 5 as a factor sitting there? Do you see the x squared sitting in there all the way along? Okay. Because one of the things we're going to have to do is undistribute. But we continue multiplying. Now I'm using an acronym that I'm assuming you have probably run into in the past, FOIL multiplication. First, outers, inners, last. When you're multiplying 2 binomials, x plus 1 times x plus 5, we can use this acronym. Now maybe your teacher did a happy face or George. I've heard a variety of things. First times first is x squared. Outers is plus 5x. Now, by the way, essentially, this is a double distributive. I distributed the x, and now I distribute the plus 1. My inners, plus 1x, and my last times last, plus 5. Now, do I leave it here? Oh, no, you say, add them up, add them up. Yeah. Don't we almost always, let's say 95 at least % of the time, we have these middle terms that add up, and we get x squared plus 6x plus 5. Now, I want you to take just a second and think with me, from where did we get this x squared? Well, that was the x times the x, wasn't it? From where did this 5 come? Well, that was the last times the last, right? And the 6x, well, he was the most complicated because he was the outers and inners combined. Okay, just something to tuck away there. We're going to FOIL again. 2x squared, first times first. Outers is plus 6x. inners minus 1x, and last times last minus 3. Again, we're going to combine these middle terms and we get 2x squared plus 5x minus 3. And again, I want you to pay attention. From where did we get this 2x squared? That's the first times the first. From where did we get this negative 3? Last times last. And this 5x is the most complicated part of that result because he's the outers and the inners combined. Okay? Well, I'm not done with you yet. 6x squared minus 21x plus 10x and a minus 35. First, outers, inners, last. And combining, we get a pretty big result here. And if you were given this answer, because remember that where we're aiming is we want you to be able to factor polynomials. And that means you're going to start with this and take it backwards to that point. Could you? Would you know how we got that 6x squared? Would you know how we got that negative 35? Okay. Now, I do want to look at several special cases here. One is when we've got this square going on. Ugh, it drives me crazy. The answer is not x squared plus 9. What does it mean to square something? It means take it times itself. Well, you have two of them, and so we end up with... Now, I did that kind of fast. Do you know where I got that 6x? That was the outers and inners added up. Okay. Well, on the 2x minus 5, quantity squared, it means take it times itself. And that would be 4x squared minus 10 minus 10 minus 20x plus 25. Hey, and while I'm here, I would just like to take a quick moment. Let's look at the signs as they appeared here. Why is it that I got a positive 25 on the end? Well, of course, that came from the negative 5 times the negative 5. And we had the negative in the middle because our outers and inners were both negative, so they had to add to be a negative. What I'd like to do is take just 1 second, and how about if we have a plus b quantity squared? Because this essentially gives you one of the special factoring forms. I don't stress it, but sometimes in higher math it's nice to be comfortable with this. That's a plus b times a plus b, and that gives you a squared plus 2ab plus b squared. And understanding that helps you in such things as complete the square, a process that you sometimes have to use. A few more special cases. First times first gives me w squared, outers, inners, and last times last. And look at what happens here. Minus 7w plus 7w, gone. So we get w squared minus 49. Well, that's kind of interesting. It doesn't look like the other answers because the other answers always gave us 3 terms. Why did it happen here? The fact that my outers and inners were going to be identical except the signs were opposite. Oh, okay. Well, do you think the same thing's going to happen here? I get 9w squared, outers of minus 3w, inners of plus 3w, and last times last of minus 1. And looky here, again, my outers and inners are identical except opposite sign, and they drop out, and I get 9w squared minus 1. Okay? And it's pretty interesting. Notice 49 and 9w squared and 1w squared. They're all perfect squares, aren't they? Why is that? Well, how did we get the w squared? We took w times w. Okay, where'd we get the 49? 7 times 7. Oh yeah, there'd be a reason why these guys are perfect squares. Why did I have to have this minus sign hitting in here? Because you're multiplying a positive times a negative. Last times last is where we got that negative 49. Last times last is where we got that minus 1. Oh, okay. Remember, if you understand really well how you multiplied to get these answers, then working backwards is a little bit easier. Last special cases, and then we're going to start the backwards process. In this case, I've got 2 terms multiplied by 3 terms, a binomial, a trinomial. And although I can't really call it FOIL, it's the same idea. I first distribute the x through, and I get x cubed minus 2x squared plus 4x. Now distribute the plus 3 through, and I get plus 3x squared, and I get minus 6x, and I get plus 12. You know what? It just dawned on me that I wrote the number wrong when I typed that on here because it's not coming up with what I wanted. So if you don't mind, well, that was fun. I want to change my number in the very beginning here. I want to change this 3 to a 2 because I was heading for a special formula and suddenly dawned on me that wasn't there. Okay, so let's do this again. X cubed from there minus 2x squared plus 4x. Then I have a plus 2x squared, a minus 4x, and a plus 8. Okay? And when I combine like terms, I have 2 pairs there that drop out, and I get x cubed plus 8. Now that's kind of a strange little critter there because you say, wow, a 3rd degree? I'm not used to those. But you might notice that this is a very special situation. This is a perfect cube and 8 is a perfect cube. So this is going to be one of our special factoring forms as well. Okay? Sorry I had that number wrong in the beginning, but that's okay. Now, last guy. And this guy is going to be a little bit strange because you'll notice that I have an x in one and a y in the other. I just wanted you to realize that sometimes I see some kind of strange messes. First times first, I get an xy. Outers, I get a minus 7x. Inners, I get a plus 3y. And last times last, I get a minus 21. And you look at that and say, there is nothing I can do with that. That is my answer for multiplying that all out. Okay? We'll also work on factoring those. All right. Now let's get going on the backwards process. If I come upon this 5x plus 15 and I'm asked to factor it, does it look like it's got the answer from foiling? Huh? Well, it doesn't have a square on it. And doesn't the foiling always kind of give me the square? But then you notice a 5 and a 15. And in fact, that's what you have to get used to looking for first. you look at that and say, oh, a 5 goes into both of those. So this is the undistribute. I can factor a 5 out. Now inside of the parentheses, I have to put the leftover, so to speak. What would I multiply by 5 to get an answer of 5x? That would be an x. What would I multiply by 5 to get a plus 15? Plus 3. And there we go. I have factored it. Now, how do I know I have factored it? Because factoring is unmultiplying. You're trying to find something that multiplies, and it needs to be something a little simpler than what you started with, okay? And x plus 3 is a very simple polynomial. I can't break him down, okay? Well, then I look at x squared plus 5x plus 6, and I say, you know, that kind of looks like the answer from foiling. Now, first off, look at each term individually. This is a 1x squared. This is a 5x. This is a 6. Do you see any common factor that I could undistribute? No. So then I'm ready to see if I can unfoil it. Okay? Now remember, how did we get this first term? Well, he always came about from multiplying first times first. So what would I multiply to get an x squared? Now I know somebody says, well, x squared and 1. No, because I have to reduce it down in degree for this to be a good factoring. So I want to use x times x. Okay? Now, some people then go to this second term, but remember, he was the most complicated, so don't go there. Go to your third term, your last term. How would I get a 6? Well, there's a couple of possibilities. It could be that I have plus 1 and plus 6. It could be that I have plus 2 and plus 3. All right? Now, as it turns out, there's only those two possibilities. Well, Mr. Gauss did assure us that there's only one that's really going to work here, so the question is which one? You can double check by foiling them out, and you'll soon see that the pair we want is x plus 2, x plus 3. And by the way, the whole key is x times x is going to give me the x squared. These multiply to give me the 6. I need to check what will give me the middle. The middle's the last thing you consider. And with a plus 3x and a plus 2x, that's where I'm getting that 5x. Yeah? So this is the correct factored form for x squared plus 5x plus 6. Okay? Now, on this one, I see 2x squared, 10x, and 12. And my eye says, man, those numbers are all even, aren't they? So guess what? I could factor a 2 out. That's called the greatest common factor. Okay? The greatest common factor of these three terms is 2. So I pull that 2 out, and remember, this is the undistribute. 2 times what would give me 2x squared? 2 times what would give me plus 10x? And 2 times what would give me plus 12? Okay? Now notice, what I did here is I factored the greatest common factor, which is a 2. And you could double check by distributing that back. Yes, that is correct. But am I done? Well, remember on that 80, after I factored once, I had to go again. Guess what? I have to go again. But look, I know how this guy factors. I just did it. So I get 2 times x plus 2 times x plus 3. you have to factor these guys sometimes more than once. Okay? By the way, notice it says factor completely, not just once. All right? Going on. Oh, good gracious. This first one just looks like a horrible mess. So he immediately says to me, oh, please find a greatest common factor. And I look at each of these terms individually. Is there a number that would divide into each of the 9, 15, and 6? Yeah, I think you see a 3 there. Okay, so I can factor out a 3. And then you look to see, well, what about x's? This has x to the first, x squared, x cubed. What's the most that I can factor out of every single term? Well, the most I can take out is x to the first power. And then you look at w to the third, w squared, w to the fourth. What's the most I can bring out? The w squared. Okay? And then in parentheses, I'm going to have 3 terms because this has to distribute back to give me what I started with. Well, let's see here. What would I multiply all this garbage by to get the 9xw to the third? Well, I'd need a 3 to get the 9. The x is there. I need a w. Okay, so I get a 3w. What do I multiply by this to get the 15x squared w squared? I'd need a 5. I need an x. And I don't need a w because I have w squared and w squared. That's good. And what would I multiply times this to get the 6x cubed w to the fourth? It'd be a 2. Well, this is an x to the first. I'd need x squared, and I'd need w squared. Okay? And then you look at that mess inside of the parentheses and say, does that look like the answer from foiling? And thankfully you say no. Okay, so I'm done. That would be my final answer on factoring. Okay? Now, take a look at this x squared minus 49. Does he look kind of familiar? You might even flip back a page or two. We did him, didn't we? Now, you say, well, he doesn't quite look like the answer from foiling because he doesn't have 3 terms. But here's what you want to recognize. When you have 2 terms, you look at that minus sign. Good sign. And then you look. Is this guy a perfect square? Yeah. Is this term a perfect square? Yes. Then this is what we call a difference of squares. And if you would like, you could give yourself this formula. If you like, it's a factoring formula. A squared minus b squared. Notice it's a difference, subtraction of 2 perfect squares will go to a minus b, a plus b. Okay? So in this particular case, we would have, what squared gives me x squared? X. What squared gives me 49? 7. And then you do one of them plus, one of them minus. Why did we need to do that? Well, the reason we needed to do that is because then the middle terms will drop to 0. That's why I have 2 terms. And the last term will be negative. Hey, before we leave this guy, what if I had a squared plus b squared? What if I had a sum of 2 squares? And you say, well, try a plus b, a plus b. Because you have plus ab, your outers and inners, you would get a squared plus 2ab plus b squared. So it can't be that. Okay, so then you say, all right, we'll make one of these guys negative. Well, the good thing is I get my a squared, my outers and inners drop out, but look at what happens at the end. I get a minus b squared. See, as it turns out, this guy does not factor. This guy is prime. We have prime polynomials just like we have prime numbers. So if you have a simple, now I say a simple difference of sum of squares, he will not factor. Okay? Some of the higher powered ones do. Okay, now we've got 4x squared minus 64. And you look at that and say, oh, I see, that's a difference of squares. Oh, but hold your horses on. You always look first for a greatest common factor. Now with a 4x squared and a 64, there is something that'll go into both of those guys, and that's a 4. Now I know you say, oh, but you're going to screw up that difference of squares. No, I'm not. It'll hold for us. It'll hold. 4 times what will give me this first term? X squared. 4 times what will give me minus 64? Minus 16. Now remember, just because you factored once does not mean you're done. This guy is a difference of squares, and we get x minus 4, x plus 4. Now he is factored. And if you had just factored this in the beginning as a difference of squares, you would not be considered as having it factored completely. All right? Always go for that greatest common factor first. Okay? When I see something like this, I go looking for greatest common factor because I'd really like for the numbers to get smaller. But unfortunately, with a 5, a 19, and an 18, there's nothing common. Okay. But he does look like he has come from foiling. So he looks like I should unfoil him. By the way, do you realize that what I'm doing here is using the clues that I see? Just like I did with the numbers. The idea that seeing a number ending in 5, I know 5 goes into it. So seeing these 3 terms with an x squared and an x and a number by itself clues my head into try unfoiling him. Okay? Now, remember, you always start with this first term. What would I multiply to get the 5x squared? And you want to take it down to a lower degree, so it'd have to be 5x and 1x. It's the only way I'm going to get that 5x squared. Now, how do I get a plus 18? You have to skip over that middle term. Here's the second thing you look at. Well, let's see here. How can I multiply and get an 18? I could have plus 18 and plus 1. I could really have negative 18 and negative 1. And some of you might be saying, ooh, that's it. Hang on. The fact that these are both positive tells me that these have to both be positive because they have to multiply to be a positive, and the outers and inners must add to be a positive. Okay. Now, by the way, whatever I set over here gets multiplied by the 5, and whatever I add here gets multiplied by the 18. So that's an 18x and a 5x, so that doesn't work. But I do need to consider changing the position of those numbers, because now the 18 is multiplied times the 5. Oh, that's way too big. So that isn't it either. Okay, so then how about 2 and 9? Well, let's see here. That'd be 45. No. Okay, how about 9 and 2? 10, 9. There we go. Now, there are some people that teach processes, and if you effectively use a process, that is awesome. My experience has been that very often students will forget the processes, and that's why I actually prefer trial and error as a method. Now, again, if you have a process and it works for you, awesome, keep it. Okay? Now, I have my pair here that's going to work, it's going to be 5x plus 9 and x plus 2. Now, a good idea would be, if you decide you want to double check this, do this on a piece of throwaway paper, because I've seen students factor and then double checking it, multiply back, and then take that as their answer and end up in trouble, okay? Next guy. I look at this and I see, wow, 3, 15, 18. I see a 3 going into all those. And look at these x's. Look at all these x's around here. So as it turns out, I have a greatest common factor. You want to get used to looking for them first off and pulling them out. So my greatest common factor is a 3, because 3 will divide into all of that, and an x squared. So when I factor that out, I get, let's see here, 3x squared times. What would you multiply times 3x squared to get this guy? It'd be an x squared. What do you multiply by 3x squared to get this term? It'll be a 5x. And what do you multiply by 3x squared to get this term? Minus 6. Now I'm being kind of funny here, because you might look at that and say, oh, we've factored that before. Oh, but look carefully. What we factored before was x squared plus 5x plus 6. Believe it or not, that little sign makes a big difference. Okay, so let's see if we can get this guy factored. This looks like the answer from foiling, so I'm going to try to unfoil it. It would have to have an x coming first, and then, let's see here, to get a negative 6, oh, it has to be negative? Well, that means that I could have like a positive 1 and a negative 6. And if you check outers, negative 5x, inners, plus 1x. Oh, that gives me a negative 5x. So then you say, well, what if I just switch these signs? Positive 6x minus 1x. There you go. It's going to be 3x squared times x minus 1 times x plus 6. Okay. Now, if you're not feeling real comfortable with the factoring, you may need to do some more multiplying in order to start to see the interactions of what's going on here. Now, this guy, the last on this page, my first thought is, oh, I hope I have a greatest common factor with a 4th power, but I don't. Well, the greatest common factor is 1, so it doesn't help me. But then I look at it a little further and I say, ooh, I see a minus sign, and is there something that times itself gives me an x to the 4th? X squared. Something times itself give me 16? 4. Okay, so this would be our old difference of squares right here. And what's really nice is once you recognize that you have a difference of squares, it factors very quickly. What squared gives you the first term? What squared gives you the second term? One of them is plus and one of them is minus. Okay, so this is going to be x squared minus 4, x squared plus 4. And then you look at that and you think, well, now wait a minute. These are kind of big, so maybe I'm not done. Can I factor this down? I see 2 terms, a minus sign. This is a perfect square. This is a perfect square. So that would be x minus 2, x plus 2. Okay. Now, what about this x squared plus 4? Can I factor him down? A sum of squares is prime. Okay, so he's got to stay x squared plus 4. So here is my factored form. And one of the things you're going to find is that when we start solving equations and inequalities, factoring is a huge benefit to us. Okay? All right, continuing on. Factor completely. And we see this x cubed plus 8. X cubed plus... Didn't we see that guy once before? Let's go back here somewhere. It was somewhere in all this multiplying baloney, wasn't it? Yeah, look at this, because I had to even correct him. Now, since these guys multiplied to give me an x cubed plus 8, guess what? I know how he factors. He factors back to this. Oh, okay. And I know you're still saying, yeah, I so would not have done that. Okay? But here's what I want you to notice. Greatest common factor is 1, so I can't pull him out. I see a plus sign. This is a perfect cube. This is a perfect cube, 2 to the third. So this is what we call a sum of cubes. And there's a special factoring form for sum of cubes. If I have a cubed plus b cubed, these guys will factor. And by the way, I think what I'll do is go ahead and give you the minus as well, because like in this case, one of these guys factors and one doesn't. In the case of the cubes, 2 perfect cubes, we can factor either a sum or a difference, okay? Now, here's how I remember it. I actually have this all in my head in words. I don't have it in the symbols because that's just gobbledygook to me. In my head, I have what cubed gives me this guy, what cubed gives me the second term. And in this binomial factor, my sign stays the same. Meaning that if it's a plus here between my cubes, it's a plus. If it's a minus here between my cubes, it's a minus. Now, the other factor, in order to get all the way up to this third power, and I've seen it happen back there where I multiplied, I've got 3 terms. And the first term is this guy squared. The third term is this guy squared. And the middle term is the product of these two with the sign changed. Minus plus 2, I'm sorry, no 2 on that. No 2 on that, just AB. Okay, so again, in words, what I say is, what cubed gave me the first one, what cubed gave me the second one, and the sign is the same. Then it's first guy squared, second guy squared, product of the 2, and change the sign. Okay, let's try that right here. What cubed gives me x cubed? X. What cubed gives me 8? 2. Sign is plus, plus. Okay, that was really easy. Now, for the trinomial factor, because this is a great big old cubic, so I have to have a more complicated answer. It's this guy squared, this guy squared on the end. And then in the middle, it's these 2 guys multiplied together and change the sign. There you go. After you've done a few of these, they're not hard to factor. And again, if you want to improve your comfort level, then go ahead and multiply all that out and see how it interacts. Okay, I look at this mess and I say, oh, 8, x cubed, 27, blah. Greatest common factor is 1. Minus sign. Now, is there something which cubed gives you 8x cubed? 2x. Is there something cubed that gives you 27? 3. So this is a difference of cubes, one of our special factoring forms. And that would be then 2x minus 3. Notice I kept the sign the same. And then in the trinomial, I would have this guy squared, 2x times 2x. This guy squared, the product of the 2 in the middle, that's a 6x, and change the sign. Hey, and by the way, unless it's a very special situation, these do not factor over the real integers. Okay? Now, this last thing that I'd like to do, and we may not do all of these, is when you see 4 terms, you look at them and say, oh my goodness, 4 terms. We did one of these back a ways where we had 4 terms when we multiplied. What you want to do is this. You want to group them. Now, we don't talk about another kind of grouping, which is a possibility. We pretty much focus now on just grouping in pairs. And then what I want you to do is, looking at these 2, what's your greatest common factor? That'd be a 5. And when you factor 5 out of just these 2 terms, you get x minus 3y. Okay? Now, ignore those 2 and just look at these last 2. What's the greatest common factor? And you see that a 2 and a z. So I say plus 2z. And then what's left? X minus 3y. Now you might want to take a second and make sure that if you distribute these through, you get to where we started. Because now I'd like you to notice that you essentially have got 2 big, ugly, ugly terms. And you say, look, they have a common factor. This guy has a factor of x minus 3y. This guy has a factor of x minus 3y. So I effectively factor out greatest common factor of x minus 3y, and I'm left with 5 plus 2z. Wow, that's kind of cool. And I think we'll just do this last guy, or this will be our last guy. Look at the first 2 terms, because I've got 4 terms, and the greatest common factor of all 4 of them is 1. So I decide I'm going to pair them off. What's the greatest common factor? I can take out an x squared, and I would be left with 2x plus 5. Now you look at these 2 guys and you say, well, what can I factor out? 9 is the biggest number. But then if you factor 9 out, you might realize that you're left with 2 negatives inside, and so it doesn't take too long to realize, oh, factor out a negative 9. Because if I factor a negative 9, I'm left with 2x plus 5. And you see, after you've done these factoring of 4 terms, you start to realize exactly where you're heading. Remember how I started out talking about when you factor number, you're looking for clues. We're also looking for clues here, or Q's. And I need this common factor of the 2x plus 5, because then I can complete this by saying 2x plus 5 is being multiplied times x squared and a minus 9. And as soon as you write that x squared minus 9, you should realize, oh, that's a difference of squares. So I can factor this down and get x minus 3, x plus 3. Okay? Wow, that's pretty big to factor those cubics. Now, we've done lots of factoring here. And remember that factoring is basically unmultiplying, so if you're not comfortable with the factoring, you might want to do some more multiplication, looking for those clues, what's happening, okay, so that you can go backwards more efficiently, okay? With practice, you start to recognize pretty quickly when you might have a difference of squares. That helps you in factoring. Or if you have a difference of cubes, difference or sum of cubes. Maybe you have the result from foiling, the result of foiling, okay? Or if you see 4 terms when you need to factor by grouping in pairs. But always, always, always check first for that greatest common factor. Now do some real good practicing with this, because just like working with the numbers, the more you factor these, the more proficient you will become with them. Okay? Thank you.